Hello everyone. Today I am going to give you a brief introduction about ultrasonic machining. At the end of this sessions, you have learned about introduction about USM, its working principle, USM machines and different parts, how USM works, effect of a slurry tool and work materials, USM applications and its advantage and disadvantages. Ultrasonic machining is a non-traditional process in which abrasive contained in a slurry are driven against the work by a tool oscillating at a low amplitude about 25 to 100 microns and high frequency like 15 to 30 kilohertz. You must know what the difference between frequency, wavelength and amplitude, because it's all are related to ultrasonic machining. First of all, frequency tells us how many waves pass through a point at a second. Then wavelength tells us the length of those waves. And last, amplitude tells us how big the wave is. Principles means the machining zone is flooded with hard abrasive particles, generally in the form of water-based slurry. First, when the tool vibrates over the workpiece, abrasive particles act as intender and intend both work and tool materials. In ultrasonic machining, material removed is due to crack initiations, propagation and brittle fractures of materials. USM machine parts, some important parts. First of all, high power sine wave generator. Second one is a transducer. Then third one is tool holder or horn. And next is tool. High power sine wave generator. It is used for convert low frequency about 50 Hz electrical power to high frequency about 20 kilohertz electrical power. Transducer. The high frequency electrical signal is transmitted to transducer, which converts it into high frequency and low amplitude vibrations. The ultrasonic vibrations are produced by the transducer. The transducer is driven by suitable signal generator followed by power amplifier. The transducer for USM works on the following principles. First one is piezoelectric effect. Second is magnetostrictive effect. Third one is electrostrictive effect. Piezoelectric effect transducers works generate a small electric current when they are compressed. Also, when the electric current is passed through the crystal, it expands. When the current is removed, crystal attains its original size and shape. Such transducers are allowed up to 900 watts. Piezoelectric crystals have high conversion efficiency of 95%. Generally used magnetostrictive transducer because it is most popular and robust amongst all three. Magnetostrictive transducer, it is also change its length when subjected to strong magnetic field. These transducers are made of nickel alloy sheets, and their conversion efficiency about 20 to 30%. Such kind of transducers are allowed up to 2000 watts. The maximum change in length can be achieved is about 25 microns. A tool holder or horn. It is also called as concentrator. The tool holder holds and connects the tool to the transducer to virtually transmit the energy and in some cases amplifies the amplitude of vibrations. Material of tool should have good acoustic property, high resistance to fatigue cracking. Due to measures should be taken to avoid ultrasonic welding between transducer and tool holder because they create deficiencies. Commonly used tool holders are titanium and stainless steel. Tool holders are more expensive and demand higher operating cost. The horn or concentrator can be different shape like exponential, tapered or conical or stepped. Machining of tapered or stepped horn is much easier as compared to the exponential one. You can see in figures the different horn used in USMs. First one is exponential, second is tapered, and third one is stepped. Tools are made of relatively ductile materials like brass, stainless steel, or mild steel, so that tool wear rate can be minimized. The value of a ratio of tool wear rate and metal removal rate depends on kind of abrasives, work material, and tool material which we have used as a tool. Ultrasonic machining process. As the tool vibrates with a specific frequency, abrasive slurry, usually a mixture of abrasive grains and water of definite proportions, is made to flow through the tool work interface. The important force arising out of vibrations of the tool and the flow of slurry through the work tool interface actually causes thousands of microscopic abrasive grains to remove the work material by abrasions. Material removal from the hard and brittle materials will be the form of sinking, engraving, or any other precision shape. Material removal models in ultrasonic machine. Some of the models used in USM, ultrasonic machining, are as follows. First one is a throwing of abrasive grains, hammering of abrasive grains, cavitations in the fluid medium arising out of ultrasonic vibration of tool, chemical erosion due to microagitations. Material removal due to throwing and hammering is significant, and metal removal due to cavitations and chemical erosions can be ignored. Effect of slurry, tool and work material. Metal removal rate increases with slurry concentration. Slurry saturations occurred at 30 to 40% abrasive per water mixture. Material removal rate drops with increasing viscosity. The pressure with which slurry is fed into the cutting zone affects metal removal rate. In some cases, metal removal rate can be increased even 10 times by supplying the slurry at increased pressures. In the shape of the tool affect in the metal removal rate. Conical tool gives twice more compared to cylindrical tool. Metal removal rate is higher than cylindrical tools in conical tools. Brittle material can be cut at higher rates than ductile material. Applications of a USM. USM has a large number of applications. Some of them are machining of cavities in electrically non-conductive ceramics, used to machine fragile components in which otherwise the scrap rate is high, used for multi-step processing of fabricating silicon nitride turbine blades. Large number of holes of small diameter could be machines used of machining hard, brittle metallic alloys, semiconductor, glass, ceramics, carbide, extras. Used for machining round, square, irregular shape holes and surface impressions. used in machining of dies for wire drawing, punching, blanking operations. USM has many more applications, unlimited applications. Like there are advantages. Every machine has many advantages, as well as USM also have some advantages. It can be used in machine hard, brittle, fragile, and non-conductive material. No heat is generated in work, therefore no significant change in physical structure of a work material. Non-metal, because of the poor electrical conductivity, that cannot be machined by electrodischarge machine, and electrochemical machining can be very well machined by ultrasonic machine. It is burless and distortion-less processes. It can be adopted in conjunction with other new technologies like ADM, ECG, ECM, and many more. Every machine have disadvantages. USM also some have low metal removal rate. It is difficult to drill deep holes as slurry movement is restricted, because in USM we are working with the slurry. Tool wear rate is high due to abrasive particles. Tool made from brass, tungsten carbide, MS means mild steel, or tool steel will wear from the action of abrasive grit with a ratio ranges from 1 proportional to 1 to 200 proportional to 1. USM can be used only when the hardness of working is more than 45 Rockwell hardness. That's it. Thank you. Thank you for watching us.